Hey everyone, I'm Yuval Fernbach. I'm VP and CTO for JFrog ML here at JFrog. A bit about myself, and then we'll dive into trust around ML. So I'm before being the CTO for JFrog ML here at JFrog, I was one of the co-founders and CTO of a company called Quack. That was an ML ops platform, and coming from a background of machine learning and machine learning in production. I was working for AWS in the past as well, also focused around their ML services and specifically around ML in production. So today I want to speak about trust and ML, and specifically not the trust on the ML accuracy or ML results, but how you can trust those solutions that you put in production that actually are eventually part of your product, and make sure that no one use those models, those products, to actually attack you or to find some vulnerabilities in your systems. So we speak about how you can actually build models that don't just give good results, but also are capable to be part of a production system. So let's just wait for the presentation to start, and the clicker doesn't work. Okay. So as I said, regarding the agenda, we'll speak about a bit about why trust in AI actually matters. What are the security blind spots around the ML and AI? Why I want to speak about this, and not just about security, but also about governance and compliance and some of the challenges that many companies currently have around running models in production. And eventually we speak about practical ways to actually solve that, or at least have more trust on those models that you build and eventually deploy in your production systems. So let's start with some statistics coming from both Gartner and McKinsey. And the reason I want to show those statistics is because if in the past, many models were built for research purposes. I said before, I'm building ML products for more than a decade now, and I've seen many cases of companies building models and using those models as part of research, as part of async processes, predicting churn and predicting, lifetime value of customers and many of those things. But nowadays, companies are actually using machine learning models as part of their production systems. Gartner are even saying that by 2027, over 90% of new applications will include ML systems, ML applications. We see that McKinsey are saying that the growth of organizations that use AI for business purposes grew from 50% to 78% in 2024. Basically, what it means is that the way companies are developing software is changing. Because if in the past, most of the software were just basically code with functions that eventually we ship to production, nowadays those applications, those software actually utilize machine learning models and AI applications behind the scenes. And it means that we actually need to trust those services and maybe even apply some best practices that we are doing for software for years now around ML as well. Just a second. Okay. So by showing that companies actually using ML more and more and actually implementing those models in their production systems, we understand that models are becoming critical assets in organizations. Models are not just for batch async processes anymore. They actually have high economic values. Models are changing revenue streams of companies. It's not new. Companies have done it for years now. We're all familiar with products like Netflix and Uber and Amazon that have done it for years now, but now it's becoming a commodity. And more companies actually utilizing models for their businesses. In addition to that, models are, just wait for, show all the slides. So models actually are driving our business critical decisions. from simple use cases like fraud detection and risk assessment to medical diagnosis and many other things. And they are deeply integrated with our system. They actually are most critical data, most sensitive data go through those models. And we're seeing the explosive growth of models in organizations. And by thinking about this and understanding that models are becoming that critical assets, we also need to remember that models are vulnerable. Why they're vulnerable? First of all, attackers also see that this growth, this exponential growth of models in organizations. Attackers understand that models are growing, more and more companies using models, and there is low security awareness in companies around models. In many cases, companies have built pipelines around their model development that do not utilize any security tools as part of the development and as part of the production of those models. And attackers, of course, understand that and take into effect the fact that it's not that difficult to add malicious code into models, and it's not that difficult to add malicious code into the dependencies of the models. And many of the MLOps frameworks are also don't take that into account. And basically, companies don't have any security tools, any solutions around machine learning model development. And if I'll, for example, look at one example of how an ML lifecycle looks like, we're already seeing two in this specific event, and I'm sure we will see more. But this is one example of how an ML lifecycle looks like. So let's say the ML lifecycle starts from getting the right data and building that data, eventually building features or data sets, then maybe taking a model from an open source repository or building a model from scratch, or even using an external API like OpenAI and others, maybe fine-tuning that model, eventually building a production system and deploying that model. But in that lifecycle, there are many different types of vulnerabilities. For example, we'll start with data. So Alex already talked quite a lot about data, but data is not just features, and data also can be vulnerable. We actually found quite a lot of compromised public data sets in the internet, in places like Hugging Face and Kaggle and others, that companies uses to fine-tune models or even take models that are trained on those data sets, and the data itself have malicious, let's say is malicious. And based on that malicious data, models are trained to be malicious as well. And it's not just the data, it's also the models. Models that currently exist in public repositories like Hugging Face are not necessarily safe. The JFrog research team actually found that currently there are more than 400 malicious models in Hugging Face. By the way, you can see this information. So if you go into Hugging Face and click on any model, you can actually see if that model is safe or not. We actually partnered with Hugging Face with this information, with this data. And nowadays, every person that tries to download the model from Hugging Face can actually see the security status of that model. But there are currently more than 400 vulnerable malicious models in Hugging Face. And when I'm saying malicious model, it's not just like a simple, exposure or something like that. We've seen cases of models that open remote shells to your system. We've seen cases of models that read sensitive operation system files. So it's not just like a simple, a vulnerability. It's actual malicious code in those models. Going through that lifecycle, the dependencies that are being used as part of the model development, and of course the model production environment as well, can be vulnerable as well. We're seeing attackers create, for example, fake dependencies, basically creating vulnerabilities and again, malicious dependencies that companies can use as part of the production systems. And attackers specifically attack the dependencies of machine learning models. And of course, it continues with more and more vulnerabilities like, for example, prompt injection that I believe many of you are familiar with and understand how it can be used and why it's something that you need to protect against. we're seeing vulnerabilities with the production system model and the way you actually use them. And of course, I did it just a second. I'm not sure why it's jumped too many slides. Okay, I'll keep talking and wait for it to go back to the. Okay, so so things like data leakage and model extraction and even the MLOps systems are being used in many cases, have their own vulnerabilities. And eventually, this is an area where we're seeing more and more attackers actually, again, aim specifically and try to find those vulnerabilities and attack specific products based on the models. And we can actually see that there are many attacks that were actually published online. So a few examples that I believe some of you know. For example, with ChatGPT, there are a survey that actually found that it's quite easy to run some, of course, prompt injections and many ways to actually attack ChatGPT and some of the models that OpenAI create. Another example that I believe many of you know, so when DeepSeek was just launched, Wiz actually created the research. They found out that they were able to get to the backend database of DeepSeek, actually see the prompt, the actual request, the questions that were sent to DeepSeek, find the API, find actual API calls, and find some of the tokens that are used to speak with DeepSeek. So many things that they were able to see. And by the way, companies are using those services for their production system. Another example is malicious code in Hugging Face, malicious models. So this is an example that I spoke about, but we actually found out that a user uploaded the model to Hugging Face, and in that model, they added a reverse shell. So basically, if anyone have used that model, they would have opened their system to that attacker to just go into their system. So this is just one example. And of course, there are many different attacks that we've seen online, many different attacks that companies have actually tried, companies actually were vulnerable for. And vulnerabilities like 1DB had a vulnerability about permission escalation, that you are able to get a root in your system. And even things like safe tensors, that's a format that's usually used to save models, and companies expect to be safe because its name is safe tensors. It's actually not safe, and actually attackers can even find vulnerabilities in this format. But before I'm speaking about actual solutions and some of my suggestion of how to solve that and how you can protect your system, I also want to speak about governance, because security is one part of trust. But we're seeing that as we grow our ML usage and as we use more and more models in production, we need to understand what's actually running there. We need to understand what is this model that's running, how this model was built. And it's not just us. Even the regulators now expect companies to know how to answer these questions. They expect us that we're using models to know, basically to answer the question of, for example, which specific model have I used? Who has access to this model? How did I fine-tune this model? Or what's the architecture that I'm using? For example, if I'm using a RAG architecture, or if I'm connecting to MCP server or anything like that, they want me to know this information and to track this information. They want me to track what are the parameters that I've used to train a model, and to track what are the metrics and the evaluation metrics. And many things we've already been tracking for years, just because this is part of data science experiments. This is part of the research. So things like hyperparameters and metrics, even things like the base model that we used, or the model evaluations or data set, we've probably already tracked. But nowadays, because we use those models in production, we actually need to track more information. We also need to track what's the actual deployment architecture that we're using, and what's the deployment configuration. And another thing is that it's not just about models that you train and fine-tune, or models that you download from an open source license, like an open source repository like Hugging Face. It's also relevant for external API models like, for example, OpenAI and like Anthropic. Even if you use those models, you still need to track all that information. You still need to understand how that model is actually being used, and what are the configuration and parameters, and basically everything related to that model. So what can you do with it? How can you actually be protected? How can you actually make sure that the system that you use, the production environment that you use, is actually protected and is actually built in a correct way? So first of all, and this is, I must say, like the my first recommendation, and I think the only thing that I want you to go out with from this day and actually implement in your system, is that reuse the best practices that you've already built for years around software development. Many things, many best practices basically were already implemented in the past. For example, I'm sure that all of your companies already run SCA tools to find basically vulnerabilities and to find the licenses that are using as part of software development. I'm sure many of our companies used SaaS tools to actually scan for malicious code and scan for 0 days. I'm sure many of your companies actually implement API security tools and firewalls and WAFs and many other security solutions around every software that you're developing. But in many cases, the ML artifacts, the ML solutions that you're building are not implemented in the same way. And my first recommendation is to just reuse or implement the tools that you're already using on your ML workloads as well. Because, as I said before, when you develop models, you probably use dependencies, and those dependencies can have vulnerabilities. Those dependencies have licenses. When you develop models, eventually, in many cases, you deploy those models to production as APIs, and those APIs can, of course, be abused by attackers. So many of those solutions relevant for those challenges as well. Second is, throughout your development lifecycle, try to track as much as possible. Let's say you are running an experiment and you change one of the parameters, track it, save it somewhere. Let's say you are using a data set, log that data set, save it with the model, make sure that you understand how that model was built. You decide to deploy a model and maybe use some kind of a RAG architecture, then actually log that architecture, log the specific vector data set that you're using, log the specific configuration that you're using. You're using an external API like OpenAI and others, and you use specific parameters on those models, then track that as well. You use a specific template for your prompt, track that. And everything that's part of your architecture, both your deployment architecture, your development architecture, track it with your model. By the way, as part of the way we implement it in JFrog, we call that concept basically an ML bomb, a machine learning bill of material. And again, going back to the first recommendation, it's something that we implemented based on our best practices from the past. So for example, with software development, many of us track everything around that software and call that an SBOM, a software bill of material, all the dependencies, all the configuration of a software that we develop. So same concept, but just about ML. Okay, all the configurations and everything around that model, an ML bomb. Third, enforce a strict governance. Control the access, the deployment, the versioning. Make sure that you understand which specific system call a model and who has access to that model. And all of that, make sure that you do that from the development phases, from the day one of each product. Make sure that you embed that security and that governance starting from the development phases, through the validation, the evaluation, and eventually, of course, as part of your production environment. So those are my main recommendations of how you can actually solve that challenge. And again, I think that many of those challenges are not new. Yes, ML is a bit different. There are more challenges with ML. We use more open source solutions and we use external providers. The development lifecycle is different. Even the developers themselves, in many cases, are different. It's not just software engineers, it's also data scientists. But eventually, we're building systems, we're building software, and many of the best practices are relevant for models exactly the same way as they were relevant for any type of software for the last, I don't know, decade. So when I'm speaking about a secured MLAI pipeline, basically, it's the same pipeline, but think about how we can secure each step of that pipeline. So if you're speaking about data sets, for example, validate those data sets. Make sure that they are not vulnerable. They don't have any malicious data in them. By the way, even in Hugging Face, for some models, there is a tag if that model was trained on a malicious data set, but of course you need to also validate it yourself. Model poisoning, so I talked about the fact that nowadays in Hugging Face, we are actually scanning models and putting that directly in Hugging Face. You can see that information there. So make sure that you use only safe models. Prompt injection and any kind of API security, that's something that you need to protect against. So there are already some API AI gateways and API security solutions that you can use. Configure guardrails also to make sure that you protect against those kind of inputs to your models. Make sure that the dependencies that you use don't have any CVEs in them and that they are also safe. And eventually, when you're speaking about a production system, about the deployment, then again, it's not just the data in the model, it's also the architecture that you use. Because models use a lot of resources, then the ability for attackers to actually get to a denial of service is way easier. So things like scalable deployments and things like rate limiting and circuit breakers are really relevant for those specific type of deployments. Make sure that you implement that and actually relevant for even for cases of those kind of attacks or even just a regular load. So I will speak the governance part for now, but I already spoke about all of that. So again, make sure that everything regarding the models that you build is being tracked. To summarize this, first of all, trust in AI is critical. As I said, models are becoming critical assets. Without this trust, we are seeing that adoption stalls. By the way, we're already seeing that. If 2 years ago, a year ago, many companies talked about AI and about the fact that they will shift AI to production, many companies actually posed that, developed only for their internal use cases, and only this year actually implemented production system, and that's because of trust. Security blind spots are real, and make sure that you are protected against them. Governance in many cases is missing, so make sure that you track everything around your model development. And as I said before, practical solutions already exist. You already implement them with your software development lifecycle. Use the same practices, use even the same tools. First of all, implement that on your ML development and make sure that you understand what are the risks with ML development. So thank you very much and enjoy the rest of this event.